The universe whispers secrets not just in the stars, but in the machinery of life itself. For centuries, we viewed biology as simple chemistry, but a profound shift is underway. We now know that quantum mechanics, the bizarre rules of the subatomic world, is the hidden engine of life. While classical physics explains molecules colliding, it can't account for the incredible efficiency and sensitivity we see in living systems. Nature harnesses superposition, entanglement, and tunneling to do the impossible. Take photosynthesis, the solar-powered engine of Earth. When plants capture sunlight, the energy must travel to reaction centers. If it moved randomly, much would be lost. Yet, systems show efficiencies approaching 99%. The secret is quantum coherence. The energy doesn't hop step by step. It exists in a superposition, exploring all pathways simultaneously. It's a quantum shortcut that fuels our oxygen-rich world. Then there is navigation. Birds like the European robin traverse continents using Earth's magnetic field, a field weaker than a fridge magnet. How do they detect it? They use a quantum compass. Inside their eyes, proteins called cryptochromes capture light, creating entangled pairs of electrons. These particles, linked by spooky action at a distance, sensitively detect magnetic fields, turning the planet's magnetism into a visual map. Deep inside our own cells, enzymes drive metabolism at incredible speeds. They shouldn't be this fast, according to classical rules. The answer lies in quantum tunneling. Instead of climbing over energy barriers, protons simply tunnel through them, vanishing and reappearing on the other side. This quantum trick makes life fast, efficient, and resilient. And perhaps the greatest mystery of all, consciousness. New theories propose that microtubules inside our neurons harness quantum superpositions. Your very thoughts, reading this now, might be echoes of a quantum dance evolved from ancient biological tricks. These discoveries transform our view of reality. Life isn't just matter reacting to physics. It is quantum ingenuity harnessed for survival. From sunlit leaves to navigating skies, and even to our mindful reflection, the universe's deepest rules pulse within us, connecting the smallest scales to life's grand tapestry. Building on the quantum foundations woven into life's simplest processes, the human brain emerges as the ultimate frontier, a symphony of 86 billion neurons, each a bustling hub of electrical and chemical signals, orchestrating everything from basic reflexes to profound insights. Yet amid this complexity, questions linger. How does the brain bind scattered signals into a seamless tapestry of experience? Why does consciousness feel unified, subjective, and irreducible to mere computation? Emerging evidence suggests that quantum effects, already proven in photosynthesis, navigation, and enzymes, may extend into neural architecture, offering answers that classical neuroscience alone cannot provide. Microtubules, those cylindrical protein networks threading through every neuron, take center stage here. Composed of tubulin subunits arranged in helical lattices, they do more than provide structural support or transport cargo. Their nanoscale cavities and aromatic structures create environments ripe for quantum phenomena, where electrons delocalize and vibrations propagate coherently. Recent spectroscopic advances, including ultra-fast laser techniques refined in 2025 and 2026, have captured these dynamics in living tissue. Studies on isolated tubulin and neuronal cultures reveal quantum beats, oscillatory coherences, persisting for nanoseconds to microseconds at physiological temperatures, far longer than theoretical decoherence limits once predicted. These vibrations, often in the terahertz range, involve collective modes where thousands of tubulins synchronize, potentially shielded by surrounding water layers or actin filaments that act as quantum insulators. In essence, microtubules may function as biological waveguides, channeling quantum information across the neuron without immediate collapse. This isn't abstract speculation. Experiments disrupting these vibrations with specific electromagnetic fields alter neuronal firing patterns, hinting at a functional role in signal amplification or timing. The Orch-OR model, orchestrated objective reduction, builds on this to propose a quantum origin for consciousness. Superpositions in microtubule networks accumulate, representing preconscious possibilities. Multiple neural configurations explored simultaneously. When the superposition reaches a critical mass, self-induced collapse occurs due to space-time curvature, a gravitational threshold where quantum gravity intervenes, selecting one outcome. Each collapse corresponds to a discrete now, a moment of awareness binding sensory inputs, memories, and emotions into qualia. The raw, subjective feel of seeing red or feeling joy. Unlike classical models where consciousness is an emergent illusion from complexity, this views it as fundamental, rooted in physics' deepest layers. Supporting clues come from anesthetics. Compounds like halothane dampen microtubule vibrations without fully halting synaptic activity, precisely correlating with loss of consciousness. In 2025 clinical imaging, patients under anesthesia showed reduced quantum-sensitive signals in brain scans, bolstering the link. Critics argue decoherence is too rapid in the brain's warm milieu, but counter-arguments grow stronger. Biological systems may exploit decoherence-free subspaces or environmental noise to stabilize states, as seen in quantum error correction analogs. Simulations in 2026 using quantum computers model microtubule arrays, demonstrating how entanglement could link distant neurons instantaneously, solving the binding problem, why vision, sound, and touch merge into one experience. If true, creativity and intuition might stem from quantum exploration of possibilities, while free will finds footing in indeterminacy, not deterministic chains or pure randomness, but genuine openness at each collapse. Extending further, if quantum processes underpin mind, they echo the universe's quantum fabric. Entanglement, non-locality, these mirror how consciousness integrates disparate parts into wholeness. Panpsychism variants suggest proto-awareness at quantum levels, combining into complex minds like ours. Your brain, then, isn't an isolated fortress. It's a quantum resonator tuned to reality's probabilistic hum. Every thought, every epiphany, pulses with the same weirdness that powers stars and subatomic dances. This quantum lens redefines us. Not mere biochemical machines, but participants in a cosmos where mind and matter entwine. As research advances from lab-grown neural organoids exhibiting quantum traits to AI hybrids mimicking microtubule computation, the implications unfold for medicine, philosophy, and our sense of self in an infinite, interconnected universe. The bridge from quantum biology to consciousness is where science meets our deepest philosophical questions. How does a physical brain give rise to the private, vivid world of our subjective experience? For decades, we've modeled the brain as a complex computer of 86 billion neurons. Yet this model leaves a gap. It doesn't explain why information processing feels like something. Enter the orchestrated objective reduction, or Orch-OR theory. It suggests the answer lies deeper, within the quantum processes of microtubules inside our neurons. Microtubules aren't just scaffolding. They are dynamic structures where electrons can delocalize, creating coherent quantum oscillations, a hum of energy protected from thermal noise. Recent biophysical measurements have revealed that these coherent states can persist for nanoseconds, allowing information to propagate across the cell without breaking down. In this framework, superpositions of tubulin states represent multiple possibilities at once. These build up across the neural network until they reach a critical threshold. When the threshold is met, the superposition collapses spontaneously. According to Penrose and Hameroff, each collapse is a discrete moment of consciousness, a spark of now. This mechanism solves long-standing puzzles. It explains how scattered brain activity binds into one coherent experience and offers a mechanism for genuine free will beyond simple determinism. Empirical support is growing. We know that anesthetic gases, which switch off consciousness, specifically bind to these microtubules and dampen their quantum vibrations. And experiments on brain organoids show that applying fields tuned to microtubule resonance alters their activity, suggesting quantum coherence is functional, not accidental. Skeptics argued the brain is too warm and wet for quantum states, but nature seems to have evolved specific biological mechanisms to protect and extend this coherence. Just as plants use quantum efficiency for photosynthesis, our brains may use it for the emergence of mind. Consciousness isn't an anomaly. It's a natural expression of reality. This reframes our existence. We are not passive observers. Our inner quantum events echo the probabilistic dance of the universe itself. Your experience right now, curiosity, wonder, maybe the universe becoming aware of itself, one quantum collapse at a time. The implications of quantum processes in the brain extend far beyond explaining the mechanics of awareness. They begin to reshape our understanding of reality itself, blurring the line between the inner world of mind and the outer cosmos. If consciousness arises from orchestrated quantum collapses in microtubules, then subjective experience is not an accidental byproduct of neural complexity, but a fundamental feature tied to the probabilistic structure of space-time. Each moment of now, the instant you feel the warmth of sunlight on your skin, the sting of regret, or the spark of a new idea, corresponds to a gravitational objective reduction event, a tiny but real intervention of quantum gravity at the biological scale. This places mind squarely within physics, not hovering above it as some mysterious epiphenomenon. Consider the scale. A single conscious moment, according to refined Orch-OR calculations updated with 2026 gravitational models, involves roughly 10^9 to 10^11 tubulin dimers, acting coherently across cortical regions. These events occur at frequencies matching gamma band synchrony, 40-100 Hz, aligning with perceptual binding and the subjective flow of time. The brain, therefore, acts as a biological quantum computer of extraordinary sophistication, not processing bits like silicon chips, but orchestrating space-time curving collapses that select reality from possibility. This framework resolves several paradoxes that classical neuroscience struggles with. The unity of consciousness, why you experience one coherent world rather than a cacophony of disconnected modules, finds a mechanism in non-local collapse. Even altered states, dreams, meditation, psychedelics, could correspond to modified coherence levels or altered collapse thresholds. Critics of quantum consciousness often cite rapid decoherence, yet ongoing research counters this forcefully. Experiments reveal protected subspaces where coherence lifetimes reach microseconds. The cosmic connection deepens further. Quantum gravity, the missing link between general relativity and quantum mechanics, is precisely what triggers objective reduction in Orch-OR. Practically, these ideas already influence fields beyond philosophy. In medicine, understanding microtubule quantum dynamics could lead to new therapies for disorders like Alzheimer's. Ultimately, this quantum view of mind invites a profound shift in perspective. You are not a passive observer trapped inside a skull. You are a quantum participant. The answers may lie not in distant galaxies alone, but in the silent, vibrating lattice inside every neuron, the place where quantum reality becomes conscious and the universe knows itself.